initial consideration before going for a designing of an curved beam. Quite earlier sessions, we discussed about the two parameters that need to be taken care while designing a curved beam. One, as I said, would be a geometrical constraint. Second one, where the load is applied, whether on the axis or away from the whole member elemental axis. Today's example is this hook of a geometrical constraint, rectangular in cross section. And the second thing, the load is on the axis of an member. So while this, the consideration to be made, as usual, I'm going to copy a same rectangular cross section over here, which states to be of some dimension B and of some H. So this dimension states to be B and this dimension H. Two axes, one center of this whole element, we call it as a centroidal axis. You know very well that all the class I do mention for centroidal axis as C. And another one is neutral axis, which is away from a centroidal axis towards a whole member elemental axis. So where the neutral axis lies somewhere over here. I call this as N. Offset of those two axes is said as E. I do term this as E. Now, since centroidal axis is the center of the element, I'm going to divide these two into a parameter set as C. The distance between, or the distance from the elemental member axis to the center axis, I do denote it as R. A distance from a member axis to the inner race or inside race, I do call it as Ri. The distance between the member axis to the outer race of an curved beam or a member, I do term this as RO, outer. A distance from a member axis to the neutral axis, I call it as RN. Two other parameters need to be considered over here, that is a distance from an outer race to the neutral axis. This distance, I call it as CO. Similarly, a distance from neutral axis to the inner race or inner part of a member, I call it as CI. So this is the basic parameters that need to be taken in care before going for a designing of a curved beam.